Here I go. Make sure everyone's listening. Okay, let's do the ones with the infinity real quick. And let's see if y'all remember the rule. I'm going to start with number 5. If I have the highest power on the top and the bottom, and it is higher on top, is it getting closer to 0 or closer to the infinity? Infinity. So I know this one has to be infinity. For all of the infinity ones, how about I go ahead and write the rules? You guys ready? So if I have high power over the low, it's going to be slant, meaning infinity. It could also be negative infinity, depending on whichever that infinity is actually going to. But in this case, we have a positive infinity.
How would it be a negative infinity? Would it be like under the limit?
Only if it have an odd power. If it's odd power, 3 negatives becomes 1 negative. Okay? And then we have low over high, meaning I call this bottom, somebody talking over me. If it is bottom heavy, it's going to equal what? 0. So again, the way I explained it earlier this year, or even in my pre-cal class, if you're holding up your hand and I put a brick on you, in your hand, and I put more and more and more, it gets bottom heavier and heavier when it sinks to the floor, and that is our 0. Okay, Jackson.
What are you saying about when it's negative infinity?
The negative would happen if it is approaching negative infinity here, and I have an odd power, that's going to approach negative in the end. Because this slant could go up, or it could also go down. If it's odd over odd, we have negative over negative, they cancel. Okay? All right. Now, if it is the same, here is the same rule. Everybody write out the understood 1 as our coefficient. All right, I'm having a hard time. Help me out. Don't start talking now. If I have the same power, which I have x squared and x squared, all we take is the coefficient 1 over 2 and simplify that. For 1 over 2, I can't simplify any further, so we're good to go. Now, those are the infinities. Let's see what would happen if a number is actually approaching a value. Okay, I want you guys to write any number, and any number I'm just going to write 2 just because it comes to my mind. And if I have a very, very small decimal, this one is going to reach a positive infinity. Oh, yeah, of course. But if I have some number and I have a very small negative, and that means many, many zeros, and then 0.1, I guess, at the very end, that's going to give me negative infinity. And that's what this is involving. So if I were to go ahead and give you a specific number, 1 over, a number that is directly next to 3, but to the left, it's going to give me 2.9999, how many ever you want, minus 3. That denominator is going to create a very small positive or negative. The denominator, very small negative. So I know this is going to be negative infinity. On your AP test, you'll either see negative infinity or does not exist. They are interchangeable. You'll never ever see these two as an answer choice at the same time. You'll either see negative infinity or just does not exist. Okay? So now let's go on to number 6. And for those of you guys that made cards with me, let's find the first card that we made together. If you don't have it, that's fine, because this is being recorded, okay? So we're looking at continuity. And continuity was from chapter 1, again, our first card we made. And we basically wrote a card, a way to remember how to prove them. So if you don't have it, just look up at the board. All right. I'm going to bring this one down here. It's kind of sketchy right now. All right, I'm going to start writing. If you're ready, give me a thumbs up, guys. And actually really be ready, okay? All right, so on number 1, notice we have, not number 1, number 6, notice we have something on the left and something on the right. So I'm going to write out, the first condition is saying everything on the left, and the second one says greater, meaning everything on the right. So we need to figure out, is my left limit and the right limit agreeing with each other? So does it actually have a limit is basically the phrase. So let's all write out the following. limit as x approaches 2 from my left. That negative power means from my left. Of the function, in this case our function is 2x minus 1. And until we plug it in, we have to write them all out. But now that I'm going to plug in the 2, let's go ahead and put in, we have 2 times 2 minus 1. What number is that approaching? 3? Let's see if that is the same on my right. So I'm going to change my color. Limit as x approaches 2 from the right side. And it says, if you're on the right side, use this function. And I'm going to write out 3x minus, someone's talking again. Oh dear. 3 times 2. And I have minus 3. What is that number approaching? 3. And now that I have the same piece, we know the limit does exist. And the way to write this down will be, I'm going to write up here. Limit as x approaches 2 in general of the function is equal to 3. And you'll write, yes, it does exist. So my second condition says, now plug in the actual point and see if the point does exist. So our point here is always common, always, always. So I have my function of 2. But do you guys see the first one has equal to? The equal to piece is what we are going to use. So I have 2 times the 2 minus 1. And that number is also 3. So it does exist. And here's a good thing. The fact that my first limit and my second point are identical, I would write out the limit as x approaches 2 of the function is also equal to my point. That was my point, that was my limit, and they are identical. So all we have to now say is copy this piece right here. F of x is continuous at x equals 2. The beauty of the AP test, even though it's not part of the AP test on Monday, is going to be the fact that you copy this, knowing that it does exist, that's 1 point, okay? So when you guys are taking the AP test later on, state the obvious. That could be a point or 2, okay? So if you're thinking, should I? The answer most likely is just go ahead. You'll get more points, okay? All right, on the back. Everyone go to the back now. Let's see. Who wants number 7 as well? Do you guys also, anybody else also want number 7?
I'll do it.
Okay, let's do number 7. Okay, let's see if I have the card. It might be on the back. Hey. Okay, number 7's on the intermediate value theorem. Okay, let's see if I can bring this one up in a better way. Oh God, I need this remote to be heavier. Oh, I'm gonna add this scissor. Stay put. Oh, okay, I tried. Okay, number 7. If you're talking, hush. Okay, number 7 says intermediate value theorem. That basically says I have the low end, I have the high end. Is my number really in between? That's all that it means. Okay, so looking at this, it says use intermediate value theorem to show that the following has a 0. Now it's saying prove that it has or not. So basically we know we can go ahead and use it. So the first condition, we have to mention this. It is continuous. So let's write out the function is continuous on the interval given, which is this right here, 0 to 1. And keep in mind that intervals are x1 and x2. Okay, it's not an ordered pair of x and y. The second one then says, all right, let's now plug it in. So I have f of 0, and then I have f of 1 into this function right here. So I'm going to write it all out. 0 squared plus 16 times 0 minus 10. That's going to give us what number, guys? Negative 10. And then I have, for f of 1, 1 squared plus 16 times 1 minus 10. And that's going to give us what number? That's going to be 17 minus 10 is 7. Oh, dear.
I knew it.
I'm just going to call it a Friday thing, okay? Thank you for knowing it. So I'm going to go ahead and then say, is the actual number within? So would you agree 0 is within the given value? So I'm going to go ahead and write it in a way of -10 is less than 0, less than 7. But I also want to write it in a formal term with the y value. So I now have f of 0 was part of -10 is less than, someone talking over me. I hope you're helping somebody, and that's why you're talking. So my last statement is, we are going to say, what does that ... mean? Therefore, and I even used it in geometry. If you don't remember, that's okay. By the IVT, intermediate value theorem, the function has a 0, and we're literally copying this, guys. This right here, copying. Has a 0 on the interval of 0 to 1. And boom. All right, next page. So when the lunch happens, we can still go eat lunch and go to 21. Okay, Macy, did you have a question on the back? I know you asked about, are we going to go over these? So. Oh. Okay. For my back page, I'm going to use a brand new sheet because I got all that thing bleeding. So. All right, guys, we're on the back page. Let's start by asking me to do maybe 4 questions to begin with. Give me a number.
8, 17.
Oh, you're on it. I should say you can only go once, right?
No.
17.
You're talking over me. Tell yourself stop. Because clearly somebody else telling you to stop is not working. Hey, that worked. All right, number 8, we're just simply finding the derivative. Okay, let's see. You guys ready? What is the derivative of 4x? 4. So if I tell you what is a derivative of 4, is there any? 0. And our derivative is with the prime. There's multiple ways to write this. 0. So if I tell you what is a derivative of any constant number, any whole number, any value that is representing a number is 0. So here I go. What is a derivative of pi? 0. 3.14 is a number, 0. Okay? So then let's move on to number 13. So when you have a double prime, how many times are we taking the derivative? What is another word for derivative, guys? Slope. Thank you. What's also the other word? Tangent. Tangent line. All right. So let's go to number 13. On number 13, notice the first one does not have a prime. So we are going to find what is my first prime, meaning the first derivative. Now you guys notice that we have a product. I have an x times another sine of x. So I'm going to go ahead and take my thin pen just because I don't want to hide the number and put my parentheses. And then the rule was we derive the first, keep the second one. So what is a derivative of 1x? 1. All right, snow cone, snow cone. What is a derivative of sine? Well, on this one, do I keep it though, right? I was going ahead of myself. Sine of x. And then for product rule, we are going to multiply. And then my second part was you keep the first one. What is a derivative of sine of x? Cosine of x. Oh, God. If you want to put these in parentheses, since it kind of forces us to look at a product rule, that would be a good practice. But you don't have to. Will, wake up. All right. Let's do double prime. We ready? Okay. So on the next one, I want to rewrite this actually, just because when I have 1 times something, isn't that itself anyways? So I want to go ahead and rewrite this piece on the top. So let's rewrite this piece. I'm going to say f prime of x, when I simplify, it's going to give me sine of x. And then I'm going to write out x times cosine of x. So I'm going to give you a heads up. Everybody listen. Listen. Sine of x derivative is simply what? Cosine. Okay, that part is done. And then it says plus, but watch out for the next one. Do you see I need to use product rule right here? Yes, I do. They're being multiplied. So when I use my product rule, what is the derivative of x? 1. And I keep the second one as it is. Plus, I keep the first. What is the derivative of cosine? Negative sine. And if you have to write snow cone, go for it. And if I were to simplify this, I'm going to get, what is cosine plus cosine? 2 cosine. And then I have a negative times a positive minus x times sine of x. And that will be the best answer. Now on your AP test, what if you stopped right here for the free response? Is that allowed? You don't have to simplify it all the way, okay? But we're going to practice simplifying all the way for the purpose of multiple choice. All right. If you're ready on number 17, is that 17? Thumbs up. You guys are ready. Okay. Now, normally our variable is an x, correct? Who is my variable this time? Theta. And just to emphasize that I have two different thetas, I'm going to go ahead and put parentheses. Let's all do that. Everybody. And some people are not writing and chit-chatting. I'm going to move y'all too. And yes, it's you too. Don't ask why, because you know the reason. Okay, so let's do our product rule. So we have y prime. So imagine theta is our variable. So if you want to replace that with an x, that's fine. So what is the derivative of 1 theta? 1x. 1. I keep the second one as it is. Again, if you want to change it into the x, that's fine. I don't blame you. The second one says now keep the first one. Our derivative of our cotangent. And if you have to look at your card for today, that's okay. Just make sure you memorize it in the end. So cotangent is what? Negative cosecant squared theta. So let's simplify this. This is going to give us cotangent theta, because of my two negatives, minus, we got theta, and then, I'm going to put that in parentheses, it looks neater, cosecant squared theta. And that would be the best answer. And again, if it's free response, you may stop right here. Which one again? Right here, because I know positive theta times negative cosecant squared theta is going to give me minus anyways. Okay? All right, if you're ready on number 20, give me a thumbs up. 2-0. Sydney, ask. I do want you to simplify it all the way down for the purpose of the Google Forms. Because if there's too many options on there, it's going to be too much for everybody. You should. I'm going to cater to Sydney. Basically, if this were an AP test, multiple choice, what's the best answer? Okay? Meaning you could do everything before. All right. Let's do another quick pull. Number 20, Zoe. Put that down. Zoe, 20. All right. If your neighbor's talking, just tell them, hush. And if that didn't work, tell yourself to hush. Okay, I'm going to go ahead and look at my other card again. If we're looking at limit as something approaches 0, wasn't that basically slope of a tangent line? If y'all remember the card. So go ahead and get this card out if you want to. If you don't want to, just look at this one real quick. So we wrote, the prime is found by the following. So let's compare this. Look at the formula given. Is it identical? So we know all this is representing f prime of x. So what I want you to do is take all of this and write out f prime of x. And then I see equal to, and I see a 4. So what must be true? Look at your choices. Yes, I will. Here you go. So f prime of x, meaning the derivative of f of x, is equal to 4. And it's b. So something like this is more of like, do you know the definition? If you do, it's right there. Okay? It's kind of like if I go the answer is C and someone bubbles B, then I just walk away. There's nothing else I can do. All right, since after lunch we only have about 30 minutes or less, now I want you to do everything from 22 and on real quick with the partner, same people around you, okay? So if you have to move your desk, that's fine. Use my homework reference and I will answer questions. All right, but hold on to it.